In this video, I will show you how we can use large language models, especially Gemini 2 Flash and Gemini 1.5 Flash multimodal models, to extract structured content from the given PDF documents. So this is especially useful when you have a huge amount of documents. Those documents are unstructured data, and if you want to get data from those documents which has in the form of structured way, then we can use this technique. So why we use this one, especially like instead of OCR? So previously, like the conventional method is OCR, optical character recognition, where you pause the document, it will parse it and it will recognize the characters, and then from there you can extract the contents. So this is a typical process until now, and this process have its own complexities and difficulties involved, because the OCR tools, whatever we have until right now, does not come in par with these multimodal models, because these OCR tools have their own technique where it will fall in short, especially while there are complex documents containing both image, text, and then graphs, charts, and all. It is very difficult to get those things out from those documents. So that's why we go for Gemini 2 Flash multimodal model. So multimodal means here, like these large language models can able to process different modalities of data, especially image, text, speech, like audio, and then video as well. So it can able to process these kind of data and gives you the output. So that is one plus point here. So one more thing here is that why I'm using Gemini 2 Plus instead of other models is that it is very cheap and cost effective, and it process well up to 95 to 97 percentage accuracy. We can able to get the data. So that's one main point here. As apart from that, this model have a massive window size, like a context length. Like why means, like for example, if you want to get answers from your own documents or your own data, then you have to pass the data as a context to the model, and then prompt like how it has to behave, and from that only you can able to get the answers, like questions answered from those context. So now if usually if the context window is more, then you can pass more amount of data to that particular large language model and get the answers. So that's why especially in Gemini 2 Flash model, it says 1 million token context window. So 1 million token context is a huge size, where you can process multiple documents at one shot. That's what they say, like it can process up to 1500 pages in a single operation. I didn't test that particular capability, but the initial testing and the processing power of these particular models are very impressive. Just that it can able to process even complex PDF documents and extract data from that one. So why we need this kind of setup? Like, because if you take any enterprise, there will be large or huge amount of PDF documents. Those are all unstructured data. So a lot of information are lying around in those unstructured data. Without utilizing those things, definitely there will be a drawback. So now if we can able to convert those kind of documents in a form of structured data, then definitely it will be useful for further processing, especially if you want to process or if you want to build a application on top of this data. It is very much useful because you already have the data in a form of structured way. So it is easy for the AI to analyze those things and get the insights from that one. So that is one main use case here. So before moving on, I will show you like how exactly we can process. Here I'm having a simple image of a Q4 income statement, fiscal year 2023 income statement for TSMC. So this is the image it has. So now we are going to pause this image as a content, and then pausing question as well as a prompt, and let us see how it behaves. So okay, so now we instantiate the process. So I'm just importing some libraries, especially pandas, Google, and Google Gemini. These will be used later. So I'm setting up the Gemini model, like I'm using Google API key you can get from Google Studio or Google Gemini console. And then since I'm using Colab, there is a way to import the user key. And then I'm instantiating the client, and then I'm using the model Gemini to flash. So this is the response I got. So what is the response? I'm just passing the model name and the contents. So identify the revenue segment that contributed the most to total revenue and state its year-over-year growth percentage, and pausing the image. So this is the image I'm pausing. We already declared what is the image. So this is the answer I got. It correctly pointed out the revenue segment that contributed the most to the total revenue are HPC and smartphone. If you can see, these two are equally contributed as most, like 43% and 43%. And then the year-over-year growth percentage for HPC is 17%, and for smartphone is 27%. So year-over-year growth I asked 17 and 27. So it can able to clearly identify what exactly we are asking, and gives the answer. So now let us try with a different model. So I'm going to use Gemini 1.5 Flash instead of Gemini 2. Comparatively, it is not as superior as Gemini 2, but let us see how it behaves. I'm okay. So now let us run this one. Okay, so you can see the difference. It can able to only capture HPC, high performance computing. So it says high performance computing, but I don't know where exactly it got from that one. Okay, so it may be correct, I don't know. Most is 43%, and it experienced year-over-year growth is 17%. So it totally missed smartphone. So there is a huge gap between Gemini 2 Flash and Gemini 1.5 Flash. So it depends upon your use case, like you have to iterate, and then with a combination of different logic you can able to extract the correct data. So obviously Gemini 2 Flash is costlier than Gemini 1.5 Flash, but you get the correct output from that one. So that is one question I asked. And the second question, the explain the primary reason for decrease in operating. So this is already I ran through Gemini 2. So it gave the correct answer. So as expected, the primary reason for decrease in operating profit year over year is it is 10.4. It says okay, maybe this one. Combination decrease gross profit, okay, and increase operating expenses. Specifically, operating expenses increased to 2.2 billion, while image doesn't provide. Okay, so let me run it once again with Gemini 1.5 Flash. See how it behaves. The 10.4 percentage point year-over-year decrease in operating profit is primarily due to increase in operating expenses. So 10.4 percentage. No, it's totally missed. It is 10.4 billion, right? 10.4 billion, yeah. So wait. So what is the question asked? Explain the primary reason for decrease in operating profit year over year. Operating profit year over year. Okay. So 10.4 percentage point. Yes, that's correct. So I missed it correct. I wronged it correctly. So I read it correctly. So 10.4 percentage point. That's correct. Year-over decrease in the operating profit primarily due to the increase in operating expenses. Operating expenses. While the exact breakdown isn't explicitly stated, the visualization shows significant rise in operating expenses. That is correct. So 11% increase year over year. Okay, so this and selling and general expenses. Okay, although revenue decreased slightly. Okay, this is correct as per the diagram, as per the image. Okay, now let us test one more thing. So I tested this one with Gemini 2 actually. So the content, what it gave, I given a screenshot of a table in the form of PNG image, and then I asked to extract the contents of the image in the form of a JSON. I clearly mentioned extract the table in clear JSON format and given it and pass the image. So now you can see clearly that it extracted clearly. So Expedia, Inc. and then current share price. So everything. Okay. So share price. Okay. Market cap. Everything. It gave you structured in a structured way. So why I requested in JSON format is it is very easy to process further for downstream applications. So that's one main reason. So if you have a JSON format, even for an LLM or to store it in a database, or if you want to downstream process further, this one is very easy and less complex way to do the thing. So it extracted correctly. So for your visibility, like I put it in a table format. You can see these I cross checked already. So these things are correct numbers as per the given table. If you see mean and median, it starts with predicted data. Let us see. Yes, see predicted beta. So mean and median starts with from that column. So these things are to the mark, like 100% it was accurate. So big, since these are all table and image with clearly mentioned, it is giving the expected results. Okay, so now let us do one step further in processing and do really a complex document processing. So here what I did was I am planning to extract contents from this particular document. If you see this document contains, this is a sample analyst report, a very old one, and I want to extract structured output from this document. Structured output means I need a specific content from this document extracted as a structured output. So this document contains different images, stock prices, the stock performance, market profile, valuation, and key financial ratios, a pie chart of revenue by country, revenue breakdown, business model, all these charts and data text. For some charts, there are some explanation given here. So especially for this chart, if you take revenue by country, okay. So merchant, agency 28%. Okay. So for this data, they are given some text as well, and here if you see. So most revenue generated from United States 62%, Europe 15%, and Asia Pacific 19%, and Europe and other important. Okay, 19%. Europe, where is Europe? 15%. Okay. So now we are going to pause this document and then planning to extract structured output from different pages and different contents. So this is a simple program I created. Like if you see, I'm using Pydantic for structure output. So first I'm defining the schema as well, like how it looks like. For example, for key financial and ratios, I want to extract this particular table. So I gave what should be the schema, so that we are defining in a first hand, like how the model has to give you the content. Like for example, I'm asking I'm asking the model to give me the content in this particular structure. So that's what I'm defining previously, a structure for the content. So this is how I am defining here, and then class revenue by country. So this is one thing I want to extract, and then revenue breakdown, business model, this one. Okay, so this is from this one I want to extract. So I give a structure, like I am instructing the large language model that I need the output in this structure. So I defining the structures, and then I do want to calculate the cost as well. It may be based upon the latest one, but I roughly got the uh, pricing here. And then I'm giving the model, like I interchangeably I want to test with two different models, Gemini 2 and Gemini 1.5 Flash models. So that's what I'm using, and I'm giving some functions. So what is the first I want to count tokens and cost, and then extract data with retry mechanism. So for that I'm giving client, model name, contents. This is Gemini client, model name, what is the model, and the contents, response schema, and maximum retrace. I want to try the retry mechanism as well. And then this is the main function. So first I'm using Gemini 1.5 Flash declaring model here, and then this is the same exact report I'm giving, and giving the extraction tasks here. So for each one I give a simple prompt. So extract key financial ratios table from the document, look for the table containing financial metrics like revenue. Like, this is a simple prompt. Since I'm just iterating and testing it, if you want to do in exact if the model want to do exact identification of the part where you want to get the contents, then you can precisely give, like, you can fine tune this prompt in such a way that such that the language model can identify from where it has to extract, and also giving the schema, and as well as I want to save everything in the form of CSV file. So same for different tasks, I clearly mentioned what it has to do, and how it has to respond. Just simply printing like how the task should go. And then this is like simple, it is not a exact calculation, but a rough calculation how it can be I'm doing. And then this is where exactly, okay, so here getting the result here, this is the extraction, like doing the process how it has to do, and then counting the tokens and all the stuff, and finally getting the result. So extract data of the retry, client, model name, contents, and task, and schema. So I'm passing all those stuff, and for each and every extraction task, it does the process and gives you the output. So now let us run. I already run. So this is the output I got for the first one. So processing task, key financial and ratios. So it already saved it in the form of CSV file. And then input tokens, how much input token cost us for processing that one, and then columns I specified. So it exactly got the data as we requested. For example, if you see the data, it starts with this particular, it can able to identify this particular table and extract those data. So so total revenue, EBITDA margin, and then net income margin, interest coverage, all those things I mentioned. And these are the different columns. So 2011, 2012, 2013, 2014, 2015, 2016, and then 2017, 2018, and 2019, etc. So I'm to 2019. So if you can see, all those values are correct. I already checked. Most of, like, it is exactly as in the table. Like, for example, if you say return on equity for the year 2019, it is 4%. Okay, I think I didn't mention that particular in the schema. Let me see. Okay, so only metric, and then okay. So what are the things it extracted? Let us see. So metric, total revenue, EBITDA margin, EBIT margin, net income margin, okay, interest coverage. Okay, so it is a sample data. For the CSV we have complete data. I will run once again with the same model. So what is the model we are using here? So this is Gemini 1.5, I think. Yeah. Gemini 1.5 Flash. Okay, let us run this one. So it will take some time. Okay, so it is processing. So if you see here files, and then this is the reference number it gave back from the Gemini Google. So this you can cache it. Like for example, if you're processing the same file for different data, you can cache that particular file in the in model infrastructure as well, in Google Gemini as well, and then no need to pause it again and again. You can reference this file for this particular session, and then you can get all the data. So that is one advantage here. So there is a separate price for caching. If you see here, I can. So this is the actual pricing. For example, if you see, you can do the context cache as well. So instead of pausing again and again, you can do the context caching as well. So this is done. If you go to the files and then key financial ratio.csv, see here, it return all the details until PEG, LNT. Okay, what about other things? Maybe it is showing only those 1 to 10 items or 10 entries. Okay. Earnings per share, PG, LNT, debit to asset, total debit to equity. Where is those total debit? Okay, let me download it and see like how. Okay, so it neatly gave the output. No, so it only gave until PEGs for some reason. We need to maybe we can change the schema and then fine tune the prompt as well in order to get all the ratios, key financial ratios you need. That's one thing. And if you can see here, so revenue breakdown by business it gave. Okay, so if you see revenue breakdown by business, revenue by country. Okay, revenue by country, the second one. So revenue by country, United States 62%. Yeah. So these things are correct. So if we mostly like almost 90 above 95% all the data are correct, and it also give you the approximate cost breakdown for this particular model. Okay, oh, this is Gemini 2 Flash. Actually this is one what we ran just now. If you can see here, yeah, so this is the actual cost. The same we can test it with Gemini 2 as well. We will see. I will share, like I will save this one differently, and then we will run it again. Okay, so okay, so now I will try with the Gemini 2 model. So Gemini okay, I will run it again. I will see like Gemini 2 Flash how it whether we can able to get all KPI ratios. So it's already processed the key financial ratios. Yes, see the difference. So it can able to get all the KPIs. So we have KPIs until total debit equity. See total debit to equity. So it can able to process all the KPIs. I'm using Gemini 2 here. So advanced model compared to 1.5 flash. So this is the difference, like depending upon your use case, either you can use Gemini 1.5 or Gemini 2 flash model to extract the structured content. If it is a more complex and the data requires more analysis, then I prefer to go with the Gemini 2. There is no much cost difference here. If you see Gemini 2, this is okay, Gemini, no, 1.5 Pro, so 1.5 flash. Okay, so this is 0.075 per million token and 0.15 for the output. Yeah, so this is for greater than, okay, depending upon the token size. Output is 0.30 and 0.60. Okay, depending upon the token size. Now if you go to Gemini 2.5 flash, see 30 cents for 1 million token, and then $2.5 including thinking tokens. Okay, it can chain of thought also we can do here, and also caching we can do. So depending upon the requirement, you can either use Gemini 2.5 flash or Gemini 1.5. So I prefer using Gemini 2.5 flash to do the extraction. So these are almost like 100% correct, these values, but we need to check further. So this is what I want to show you today. Like using multimodal models, we can able to extract structured content from the given document the way you want, and then so further, since we already have an CSV file, this can be easily loaded into a database, and then that can be easily utilized for any application. It may be a AI application, or you want to do any other analytics over the one. So that will be very useful. Was mentioning Gemini 2.5, so it is not Gemini 2.5. We are using actually Gemini 2 flash. So if you can see, the input price is 10 cents, not 30 cents. Okay, so keep in mind, so it is comparatively very cheap. Input price is at 10 cents per million token, and then output price is 40 cents. You can also see that the context caching is here. The chain of thought can be only done, or thinking process can only be done in Gemini 2.5 flash. It's more advanced model. See, comparatively, still it is cheaper. It is 30 cents and then $2.50. The output is a little bit costly. But for our use case, especially if you want to extract structured data from given unstructured document, we can go with Gemini 2.0 flash. The input price is 10 cents for text, image, and video. The audio is a bit costly. Here audio means like you can even pause the transcript calls or any other meeting recordings, and from that also we can extract data. And the output price is 40 cents. So this is Gemini 2 flash, and we used two models, Gemini 2 flash and Gemini 1.5 flash. These are the two models we used here. So what I suggest is that if you want to go for a data extraction, you can go with Gemini 2.0 flash model with these considerations in mind. Yeah, thank you guys, and see you in next video.